This is a short demonstration on how to actually make a house which can be used in the classroom to demonstrate the properties and the value of insulation. It's a really simple project, and I'll run through the steps with you, and hopefully you'll try it out in the classroom and get the same success as we've had at our school here. First off, the house is actually made out of a 2 litre pop bottle, which we cut in half, as it were. Bottom half of the pop bottle we actually use as a skirt, which will actually wrap around the top half of the bottle and makes it easy to attach insulation to the skirt and wrap it around the bottle to do various tests. The top half of the bottle, once you've actually cut the bottle in half, we use a heat source within the house, which is actually a 24 watt 12 volt bulb. And if you have that set on 6 volts, it provides a nice source which gives you good results. Trying to use 12 volts, it tends to get too hot. To enable the 6 volt setting, to enable the 12 volt bulb and its stand to actually fit on the base of the 2 litre pop bottle, you need to actually cut a slot in the bottom of the pop bottle, which you do with a pair of scissors, and that enables it to fit neatly on the top. Now we need to put some thermometers in at various levels in the house. The holes for the thermometers, easiest way to do that is to use a soldering iron. Just burn the holes in, one approximately 10 centimetres from the top of the bottle, and the other one just approximately a centimetre up from where you've actually cut the bottle in half. You can actually pre-prepare these bottles. A technician can pre-prepare them by making the holes for the students readily, so they don't have to mess around with scissors. Right, so we'll have the top half as the house and the bottom half as the skirt that wraps around the house. First experiment we'll do is, every house has a loft, so let's make a loft. Just a piece of thin card, 96mm diameter. If we place that in the top of the pop bottle, you can make some templates for the students to actually just draw around the card. It's easier than them using a compass and everybody getting a different size shape. So we'll have a loft, place that on top of our heat source, and then we can take some readings at the base of the house, at the ceiling of the house, and in the loft area itself. And we'll actually seal the loft neck with some just foam sections there. So we can take the readings over about 5 minutes, students measuring the readings every minute and making a recording and seeing what the temperatures are in an uninsulated loft to start with. Then to move on from that, we can put some insulation in the loft. The easiest way to do that is to make another ring, circle of card, and place some insulation between the card. We can either use bubble wrap, we can use rock wool, we can use polystyrene, lots of different things you can use. You can vary the insulation depth, lots of different things you can do. So basic principle is the same: make 2 discs and put insulation in between the 2. They then fit again into the top half of the bottle, which can be placed over our heat source again, and thermometers placed at the various levels. Base of the house, ceiling of the house, and the loft of the house. And this time take the readings again over a 5-minute period, measuring them every minute. Now, I have some readings that I took using a Logit system which we have in our school, and using the Logit sensors, you can see the green line on that chart represents the temperature in the loft. The blue line is the base of the house, the red line is near the ceiling of the house. So you can see there's quite a lot of heat being lost into the loft, and that's taking those readings. Now with the loft insulation in, this chart shows you that, and you can see the green line now. The insulation is making a vast difference, and it actually is quite dramatic. There's about 9-10 degree temperature difference between those two readings. So really dramatic results providing the house with loft insulation. And moving on from the loft, we can also wrap various types of insulation around the house using that skirt that we made from the bottom section of the 2 litre pop bottle. The students can attach insulation, various diameters, and wrap that round the bottle and tie it with elastic band to keep it together. So we can use polystyrene, or we can use paper, lots of different insulation methods that we can use. Again, take the readings over a 5-minute period, measuring them every minute, and record the results. Another interesting concept is to use black and silver paper, which can be attached readily to the skirt again using sellotape. And on this I've actually put some heat sensitive tape which you can buy. It's extremely good. And if you wrap that around the bottle, it's readily available. You can readily see the fact that the silver is reflecting the infrared radiation and the black is actually absorbing it, and there's a visual indication, colours on the tape showing that. So there's lots of different methods and types of insulation that we can actually use and cover the house in, and the investigations can go on, and it really is. We've done it about 3 or 4 times in the class now, and it is an enjoyable activity for the students to get involved with. Hope you enjoy it. Give it a go. The cost is virtually nil. All it is 2 litre pop bottles, some thermometers, readily available bulbs and power packs that you have in the science department, and hope you enjoy the project.